Mm.
How about now? Can everyone hear me? Is that better?
Yeah.
Awesome. So I'll wait around a couple more minutes just to make sure everyone can log in. But if I could just hear how everyone's doing, I would really appreciate
Abby, it's been 50 years.
50 years. How do I? There you go. Okay, let me put record on this meeting, and so the other kids can watch it. So let me check the chat box. Oh, I got Gabby. Hello, Gabby. Good morning.
There.
I can't see. Kaina, is that you? I can't really see.
Yeah. Good morning, sir.
Morning. Landon, I see you. Good morning, buddy. Noah, is that you? Good morning, Noah. Leanna. Awesome. How's everyone doing? How's everything?
Long.
Long?
I've been in quarantine for so long. I'm tired of it.
Same. There's pretty much nothing to do except learn some math. Yeah.
I just work out most of the time because I get bored.
Oh no. I have the insanity video, so I started that. I'm not in shape at all.
Have you watched All American, sir?
No, I haven't. Actually, I just watched Frozen 2. It's pretty awesome.
It is good.
Yes. It's great. Good movie.
It's kind of used to in bed.
Yeah.
Life.
Yeah.
You know watch All American, sir. It's really good.
All American. Okay, I have to write it down some more.
It's super good.
All American. Okay.
I'm telling Angelo to hurry up.
Sounds good. I'll wait a little bit. I know. Anyone else care? I don't know. Anyone else care to share about their extended spring break?
Went to bed at 2.
At 2? Oh my goodness.
Oh, I went to bed at 3.
Oh my.
Oh,
Guys,
by an hour.
This is the time to catch up on our sleep.
It really is. I've been sleeping.
Yeah.
Listen, you're telling me that you slept correctly?
Yes, I've been sleeping early, guys. I finally have time. Like, I'm saving the hour to drive and the hour back. It's awesome. Like, that's 2 hours saved. Don't tell me he doesn't have internet, because I played video games with him, so I know he has internet, and Charlie too.
They were telling me about that. I was laughing.
Yeah, no, I suck.
Oh.
Okay. Oh, we got Lisa. And
I don't know what I did. Oh my gosh.
Albert's here too.
Okay, wait.
Ian said he can't hear anyone.
And,
Ian, unmute it. Oh, he can't hear us.
Oh. Maybe it helps to connect the mic.
I'm so confused.
Or unmute it. Okay, about 2 more minutes and then we'll start, guys.
What the heck? Oh, there you go. There you go. Oh my gosh.
I hear Lisa. Joe's here. Way to go, Joe. Elijah. Cool. Let me do this. I don't know how to do this.
Angelo said it's not working.
Okay. How do I do this? Alrighty. Maybe you could tell, did the link I posted on Google Classroom work? Because that's how I plan on sharing it every day.
Ha ha ha.
What?
Okay. Am I sharing the PowerPoint? Can everyone see the PowerPoint? It's a little quick thing. Okay,
Yes.
awesome. If you have something to write with, hopefully your notebook, if that still exists, because the printouts I'll put them, but I don't know if everyone has a printer at home. So I'm gonna try to do both, and I'm trying to keep the writing as little as possible. Okay, if we can do like a quick whip around just to know that everyone's alive and everyone's doing well. So
Name your favorite fruit.
Here.
Pineapple.
Not yours.
go for it. Go for it. Favorite fruit? Mangoes. Next.
Blueberries.
Nice.
Strawberries. Watermelon.
Watermelon.
Pineapple.
Nice.
I agree, pineapple.
Okay. I have to make a poll on this to see how it goes. Alrighty. Okay. So let me see. So I hope that everyone's doing well. People can still join the meeting. So if they're running late, they can still join, if anything. And also this video will be posted on Google Classroom and YouTube for the people to watch. Let me just make sure it's recording. Okay, yes, awesome. Okay, so as you guys know, the exam changed, right? Because we no longer will be in school for the rest of the year. Well, that's what it looks like. So I want you to know that the exam will be changing. So on April 3rd, we'll get more information. But as of right now, the exam's 45 minutes. It is 3 free response questions, and it will be at home. So for some of us, that might be really, really good. So the next concern is if you do not have a laptop. I know the 11th grade team went ahead and reached out to you and let us know who did and who didn't. But College Board is also doing their own type of deal. Where if you don't have a internet or a laptop, they might do something. So I don't know what they're doing yet, but they asked if you don't have a laptop, anything like that, fill out this little survey and I'll post this on Google Classroom. They can probably help you out, or they can give you a written test. I'm not too sure yet. Okay. Any questions so far?
Oh, it's gonna open note, right?
Sorry, unmute.
You muted
sorry,
Ian.
What?
don't know how. Let me see the chat boxes.
Yes,
Jennifer said she can't hear anything.
Lisa.
Let me see what I can do.
And
Jennifer.
Ian said same.
Nice narration, Lisa. Nice narration.
Let me see.
What the heck?
Ian, it says you're unmuted, Ian. I don't really know.
I hope no one can hear this.
Unmuted. I don't know what's happening. Did you unmute it though? I can't hear anything.
Let me see. Okay. Unmute all. Mute all. Okay. Did that work, Jennifer? No? What helped for Jocelyn is that she logged in through her phone. Maybe that can help. No? I'm not too sure,
Can
guys.
anyone hear me?
Yes, I don't know who that was.
Testing, testing, 1, 2, 3. Can I be heard?
I hope nobody hear this right now.
Okay.
God.
Okay, awesome. She is on. Awesome. So let's go ahead and continue.
Hi, Gabby. I've got you now.
Hello, guys. So I've been bugging you this week to go ahead and watch the videos from College Board. So hopefully hopefully more people did it. Shout out to Lyric for actually sending a picture of her notes. So if you haven't already done so, guys, at 1 p.m. every day, Central Time, College Board does these videos, and the people doing them are pretty legit. They're AP graders, they're high school teachers. They're teaching AB as well. However, and if you also want to learn BC, they also make videos for that too. So I've been watching every day, and they're pretty good, guys. So a lot of their material, I'm actually trying to use it here too, so I can get better also. Okay, so the approach, guys, that we're gonna be doing, the material that we've gotten as a whole idea team, we met Mr. Record here with all this pandemic. He has offered his material to a lot of people, and we took advantage of it. So this guy, he does the BC videos for College Board. So he has 29 years teaching, 24 in just calculus, and he works for NIMSI. He's an AP grader, and he's making the videos. So that's the material I'm mostly leaning on, just since I know he's been successful on it. So today's just pretty straightforward. What are we gonna learn with? So differential equation, that's our last unit. What is a differential equation? So I put this on the PowerPoint yesterday in case you haven't written it down, but I'll give you a couple minutes. What is a differential equation? So it's pretty much a function with an xy variable and one derivative of y. So pretty much, let's say y prime equals, I don't know, 2x plus y, something like that. So something that has a at least one derivative of y, or it could be y prime equals 3x something y, I don't know. Later on in the unit, we're gonna find out how to solve these solutions. So pretty much we'll find the derivatives and we're gonna go ahead and substitute. And if they equal the same function or equal 0, we can find that solution, which can be one solution or a set of solutions. So I'll give you a couple seconds in case you need to write that down.
Jennifer can't hear anything.
Not in there.
Let me see. Let me see if I can call Jennifer, maybe because she can hear through this one. Jennifer. Hello, Jennifer. Maybe this can work if I put you on phone and then watch through the phone.
OMG, I can see Lyric.
Does that make sense, or is that?
Hey, bestie.
Awesome. All right, I'll leave you on here and hopefully you don't hang up. Thank you. Awesome. Problem solved. Yay.
If you're on your phone, there's a little volume button at the top that mutes everybody. If you press it, it might work, but...
Okay, let me do that. Thank you. Got it. Thank you, Kyla. Okay, so examples of differential equations are these right here. Whoops. Pretty much what I was saying, as long as they have a derivative of y anywhere on there, and as we've seen before, we can label them as y prime, f prime, or dy dx. Okay. Now, there's something we learned in Algebra 2, so hopefully we can remember this. This is called direct variation, inverse variation. So K honestly could be any letter you want, so N, C, whatever you want. But since it's called constant, usually the books call it with a K. So K is a constant of proportionality. So direct variation occurs when it is directly proportional. So like if you were to work you would get paid per hour. So the amount of hours you work means more money. Inversely proportional occurs when it is working pretty much opposite. So if you were to be running a lap, the faster you run means the less time you took. So like so. So I'll give you a couple seconds. It's not working. So I'll leave the notes up just in case. All right, let's go with the next slide. Okay, let's start with the first example. So a particle moves along a straight line. Its velocity v is inversely proportional to the square
I can't hear anything.
of the distance. Give me a second. How about now? Can everyone hear me?
Straight up.
Yes?
Yeah.
I don't know what happened, Jocelyn.
I can still hear you.
Okay.
I can still hear you. Can you hear me?
Yes, I can hear you, Albert. Jocelyn, does that work better? No? Okay. I'll try to write it out as best I can, Jocelyn, to see how that goes. Okay. Let's go ahead and do the first example. Velocity is inversely proportional to the square of the distance s that has traveled. So we want to write an equation for this relationship. So we're talking about velocity. So velocity equals, right? Velocity is inversely proportional. So we're going to go ahead and say that the constant of variation, and inversely, as we saw from the previous slide, is division of the square of the distance s. So the distance s will be squared. That would be our solution. So we're just trying to model these differential equations. So as you can see here, guys, it does not have dv dt because nothing of this said it was a rate. Can we continue to the next example? Or any questions so far?
Wait.
Yes, Albert.
I said wait.
Let me check in on Jennifer. Jennifer, is it working? Hello? Jennifer? Okay. Is this helping out or no? Okay, awesome. Awesome, thank you.
Wait, sir, I'm confused.
Yes.
Where'd you
yes.
get that equation from?
Oh, so this is the first example. So pretty much my goal today is to find out, can we make an equation so far? So I read the question that said particles moving along a straight line, its velocity. So I got velocity that is the equals to inversely, we just learned that was the division to the square of the distance. So from here, inversely proportional is these divisions. So the constant will be divided by the value, the other variable.
Oh, wait, I need to copy that one.
Yeah. Any other questions, guys? I know it's hard to look at you guys' faces while I'm teaching. That's normally when I know when to repeat stuff. When I look at your faces and it's like, oh, it's confused. I was like, oh, okay, I need to say it again. But now it's a little difficult. Any other questions? Can I continue? Okay. All right. The next one, a puppy gains weight W as the rate approximately inversely proportional to its age. Write the equation that describes this relationship. So I have the variable right here. A puppy gains weight at a rate approximately inversely proportional to its age t in months. So I'm going to go ahead and write W equals, this right here inversely says fraction, and my constant will be divided by its variable t. Any questions so far? We just want to use the sentence and we just write it. We're just trying to introduce the scenarios right here, the modeling the scenarios. Hopefully they're getting a little bit easier. Does that make sense? Can I continue?
Go ahead, sir.
Okay, sorry about that. Okay. All right, the next example, number 3. Ooh, nice. So now this one, hopefully you can see, says rate. Let me move this right here. The learning rate of a skill S is proportional to the difference between the maximum potential learning, that's the skill M.
Didn't the last problem say rate?
I don't think so. Oh, snap. Sorry, the camera is blocking this stuff. So yes, sorry, this one also had rate. So whenever you hear rate, that's when you put the derivative. So it's going to be a derivative with W, right? Because that's the variable I'm using with respect to time is equal to K over T. Sorry. Every time you see rate, guys, you're going to put the variable, whatever the variable may be, over the time that it's using. So in this time was measured in T for months. Sorry about that. So.
Oh.
Sorry about that. Okay. Can I continue?
Only when it says rate?
Yes, only when it says rate, correct.
So when it doesn't say rate, that's when you only use the W equals and then use the
Yes.
proportion?
Like the first example. Like the first example said
Yeah, I was
just
thinking the same thing.
velocity is V. Yes? And then number 2 said rate,
Right.
so that's when it had dW dt. Is that okay with everyone? Awesome.
Does it make that obvious in AP questions?
This is just the introduction, Albert, and I'm not sure yet.
Okay.
But that is a good question. I'm not too sure yet. Where were we? Oh yeah, the learning rate at a skill S is proportional to the difference between the maximum, so difference is another key word, between the maximum potential learning and the amount of skill that is already learned S. So for me, difference means subtraction. Is everyone okay with that difference? So we're gonna go ahead and say that the rate is ds, right? ds, because that's the variable that I'm using, the rate of S, so ds dt is the difference, right? The difference, so M minus my other variable, which we set the amount of skill already learned, L. Now, however, we're missing one tiny thing, and that is the constant. So that's going to be affected to both variables, M and L. So K times the difference. Any questions so far? Are we good?
Oh, nope.
What's up, Albert?
No, hang on.
Yes. So it said rate, so I did my ds dt. Then I saw the word different, so that's subtraction. And the variables that I was given were m and l. And don't forget that there is a constant. Let me see. There is a constant always given. Okay.
Wait, don't move it yet.
And I'll try my best to post the PowerPoint before, so we won't spend that time writing down the question, because I know I don't want to suck up the whole hour per class.
All right, proceed.
Awesome. Sorry, guys. All right, sorry, guys. Okay, next question. I only got 2 more, guys, so hopefully this helps out. Let's go ahead to the next one. All right, number 4. So an IV drips administer medication to a bloodstream at a rate of 3 cubic centimeters per hour. So we have the word again, rate, and 3 cubic centimeters per hour. At the same time, the patient's organ removes the medication from the patient's bloodstream at a rate proportional to the current volume V of the medication on the bloodstream. So I'll give you guys a couple seconds. And just to give you a hint, this is going to probably be like a rate in, rate out. So we have in is 3 cubic, right? The rate out is the volume. So hopefully you were able to start it with a D. Well, if we're using cubic, this right here is a volume. So dV, dt, where T is in hours, is equal to, well, let's go ahead and think about this. What is the rate that's going out? So it's, I'm sorry, that's going in. So it's 3, right? 3 is going in. And then what is going out? Well, let's read the question again. Rate proportional to the current volume. Where is it? Where is it? There's a keyword here. Removing. There you go. This is saying that it's going out. What's going on? Well, the volume V. So minus V. Now, this is where they get a little bit trickier, but it's not that bad. You need to start thinking, well, which one of these is actually differentiable? Well, which one of these is constant? Well, we can see that at the beginning of the question, it is going in at 3 cubic centimeters per hour. So this is the same, right? No matter what, this stays the same. Same or constant. So therefore, this is not going to have a K. What is going to have a K is the volume. So this is going to have a K. Because no matter what was happening, the 3 cubic centimeters were going every hour. This would be our solution. Oh, snap. How did I do that?
Oh my God.
That was great. RIP. Okay, not to worry. That was awesome. Okay, pretty much there's a rate in, that is this right here, 3 cubic centimeters, 3 centimeters cubic. Doesn't hurt, guys. It probably even did us a little bit more help. And there's a rate out, that is the bloodstream removing it, right? Rate out, which is the volume. so V. So we need to write this as an equation. So it's d dt, right? And we need to notice that the first thing that's going, the rate that we're measuring is volume, is equal to the rate in, which is this right here, the 3, minus my out volume, which is V. This right here was constant, so the 3 will not have the K. The rate out will have the K, so it's this one right here. This right here should be our solution. Hopefully seeing it twice helped.
Go over that one more time.
Yes, so pretty much you need to notice what's going on. And it says this right here is 3 centimeters per hour. So no matter what you're doing, this stays the same, right? So this will not have the variable of constant of proportionality, the constant that we're using. However, this one right here is still talking about rate. So this one must have a K. And since we need to picture that something's going in, like the IV's dropping in medicine and the body's getting out the medicine, it has to be a difference. Is that okay?
How did you know that you had to subtract those two?
So I like to think about it like a rate in, rate out. That's how I noticed it. But this was there's a question I found because of like it was an application, but pretty much seeing the IV is administering is putting in, adding medicine to your blood at this rate. So that's how much is in here. That's how much is in your body. And then the organs are removing. So this right here, the word removing also helped me see that it was subtraction. Difference. Does that make sense?
Yeah.
Yeah. Okay. Any questions? Okay. Awesome. They're all good questions, guys. Thank you. Okay. The next question is, a chemical is diluted out of the tank by pumping pure water into the tank and pumping the existing solution out of it. So at the volume, T at any time T is this right here. So they're giving us an actual equation. Okay. The amount Z of chemical in the tank decreases at a rate proportional to Z and inversely proportional to the volume, which we know this right here is the volume. So this would be my last example. So let's go ahead and try this. So we are working with something that is changing. We're working with dt, right? Because we're working with respect to time. But keep in mind, this can change, right? But in this case, I just wanted them all to be time. And the rate that we're working with is z. So dz dt is equal to, I read inversely proportional, so I know I should have a division. Okay, so let's go ahead and begin. When you guys hear decreasing, what do you guys think of?
Down.
If yes, it's down, so a rate is decreasing, so something is gonna be negative. Okay, so the amount of Z in the chemical in the tank is decreasing, so this should be a negative K, right? A negative K, sorry, not fudge. What happened? What's going on, guys? No worries. This right here is our volume. The amount Z in the tank decreases, so negative rate of Z, so negative Z inversely proportional to the volume, which we said was this one. Okay. Sorry about that, guys. So it's dz dt is equal to what we just said, this right here, negative z, because it's decreasing, negative z divided by inversely proportional tells me division of the volume, which we know the volume is this right here. 20 plus 2t. We're missing one tiny thing, and that's the constant of proportionality. So which one is, well, we need to think about which one is constant. Since we have two variables, we have, let me go ahead and get a highlighter. We have the volume, right? The volume right here. And we have z right here. But only one of these is constant. So if we can go ahead and see this keyword right here says at any time, this is staying the same. Okay, so therefore this right here does not have the k. Is that okay with everyone? Because it's constant. So we just need.
What does that say at the top where it says any time?
Yeah, I just noticed the marker is pretty bad. Okay, so at any time means it stays the same, right? So does not have the variable k, the variable of constant of proportionality, right? So this should not have a k. The denominator should not have a k. Let's check for the other variable that we're using is z. So negative z does include rate. So therefore, this should have the variable k. So this right here is my k. This should be my solution. So you guys need to take, when you guys notice when it says rate or other keywords that say at any time, that's how we be able to decide where the k belongs. So in this case, the volume at any time told us that, hey, you know what, this is not gonna have a k. When I noticed the word rate here for my z, so therefore my z should have a k.
How do we know which one's the numerator or denominator?
Oh, thank you, Katie. So pretty much right here, the word inversely proportional, notice the two variables. So z, it came in first, so that would be the numerator to the volume. So that's how I got the denominator, and the volume was given to me here.
Okay.
Good question. This was my last example, guys. So if you have questions on this one or any of the other ones, I'm gladly here to help. Questions, concerns?
I'm sorry.
Yes.
How did you know, like, in what order to write them?
So pretty much the k is a constant. That doesn't matter as long as it's in the numerator. For inversely proportional, Jocelyn, pretty much the one that comes in first. So the proportional z is the numerator. This will be your denominator. So this is the numerator. This will be denominator. Did that answer the question or no?
Oh, okay. Okay, I see, yeah.
Yeah, so.
And then,
yes.
I'm sorry, you use dz over dt, why?
Oh, because when the rate that I'm measuring is respect to z's, where is it? To z and time.
Oh, okay.
So,
I see.
Yeah.
All right. Thank you.
No worries. Okay. Any other questions, guys?
Go over the negative z and k being on the numerator, and then the 20 plus 2t on the denominator one more time. Why is it that?
Yeah. No worries. So pretty much, let me see if I can erase it because I think I'm writing too much on the same slide. Oh, here you go, laser pointer. Okay, pretty much the negative Z came from this sentence. The amount of Z in the chemical of the tank is decreasing. So decreasing to me is negative, and the rate, the variable that I'm using is Z. So negative Z, and then, well, since it's a rate, it should have a constant K. Are we good so far for the numerator?
All right.
Then this right here, this denominator came from this sentence right here, because it's saying Z is inversely proportional to the volume, and they told us the equation for the volume is this right here. The volume at any time is this one. So that's what I got here. Is that okay?
So you're saying that the constant is going to be in the denominator all the time?
No, I'm not saying that. I'm saying that the constant, you have to check which one is changing. So in this case, the only one that's changing, the only one that has a rate is the numerator. The denominator is all the time this equation. So this right here, no matter what, will stay the same. So this has no rate. So this one should not have a K.
Oh, okay.
If
Yes.
we said increasing instead of decreasing for Z, would we leave it positive or would it like change the whole setup?
No. They will leave it positive, correct. Any other questions, guys?
No, sir.
No.
Mm-mm.
Got it.
So that was the last example. So pretty much in Google Classroom, I went ahead and put the questions, and I put some extra ones in case you needed more, would like more help, but I didn't do them that bad. So this should be a quiz trade, but unfortunately we're not in school. We can't do that. But this would have been a little fun quiz trade, and hopefully, like they're not that bad. The rate of change G with respect to T is proportional to the square root of G. So this would be something that after a little bit of practice, we can probably do in class. The only tougher ones will be 13 and 16, but they'll be okay. They're not that bad. So I made the assignment in Google Classroom, and if you guys can write nicely, because I'm gonna be asking you guys to submit the work just so I can check in case you get something wrong. I can go ahead and see your work and check it, since now I do have more time and now I can keep up with the homework assignments. Yay. And just like in pre-cal, guys, I went ahead and put extra examples, the videos to help you guys out. And also I'm available, guys. To be honest with you, I have more time now. So if you do have questions, I can help you out the best I can. Other than that, guys, I think that will be our lesson for today. So you are free to go, since I will be using this line to connect with the pre-cal kids next. And I'll upload the video as soon as both classes end. I'll put them on YouTube. But the notes and the homeworks will be up already, in case you want to start on them.
All right.
Alrighty, guys. Thank you. This was
Thank
great.
you, sir.
Hi, sir.
Bye,
Bye,
guys.
sir.
If you have
Bye.
questions,
All right,
guys, email me, text me, and I'll help you the best I can.
Yes, sir.
Awesome.
Bye. You have a great day.
Likewise. Thank you,
Ademan.
Justin.
Bye.
Bon Johnny.
Okay, Albert. Okay.
Okay, Albert.
You better not have been traveling and learn that, Albert. We're not trying to catch COVID. Miss me with that coronavirus. All right.
All right,
Bye,
guys.
guys.
Thank goodness I didn't.
Bye.
Bye.
I'll travel about. Sure, I'll travel about.
See you later.
Oh my God.
See y'all.
See you, Carlos. Bye, guys. Bye, Lisa. Bye, Albert.
Bye.